I recently coded this animation with CSS custom properties. Now I'm going to do it with Canvas. So here I have a canvas element and I have pretty much the same layout as in the previous case, and the canvas is set, its dimensions are set in viewport units, so it scales nicely. We've given it a background so that we can see it. And now for the JS, we get the canvas, document, query selector, canvas. Now we get the context and get context 2D. Next we're going to set an animation duration. Let's say this is going to be 60 frames. The next thing that we're going to do is create a function size, and we're going to get the computed dimensions and set them to the canvas width and height. But first, let's create the second function, which is going to be the animation. And it's also going to have a request animation frame. And here I'm going to have the current time, which starts at 0. So I need to bind this and increment t. And here I'm going to set the canvas width here is going to be height, and get bounding client. I hope this is the function. Okay. The next thing that we're going to do, we're going to have the radius of the big circle, and for the other two circles, so for the big circle it's going to be half the width, the canvas width, and R0 is going to be 0.25 R, so it can be anything between 0 and 0.5, and R1 is going to be R minus R0. And the next thing that we're going to do is put the 0 point right in the middle of the canvas, so that's going to be translate R. Now here actually we're going to compute something else, and this is going to be the base angle, and this is going to be pi over the animation duration. And here we're going to compute a k, and this is going to be 0.5 times 1 minus, we want this k to be between 0 and 1, so this is going to be 1 minus cosine, and I'm actually going to link to an article where I explained this whole thing, how I get this k. So this is going to be cosine of t times a, and then the current R0 is going to be 1 minus k. I have a linear interpolation. Well, k isn't linear, so it's not going to be linear, but if k was linear, it would be linear. So R0 plus k times R1, and the current R1 is going to be R minus the current R0. Next thing that I'm going to do is begin a path, and I'm going to copy paste this thing a few times, and here I'm going to have arc, here I'm going to have close path, and the last one is going to be fill, and here this arc is going to be at 0, 0, and it's going to have a radius of r, and it's going to go from minus pi to 0. Now the next one is going to be at R1, the current R1. It's going to have a radius of 0, and it's going to go from 0 to pi. Okay, now in order to prevent that, I'm going to have to clear the canvas at the beginning of each frame, and this is going to be from -r and -r, and it's going to be the entire canvas size. And this is going to be the current R0. Okay, now the last arc is going to be at minus the current R0. It's going to be 1, and it's going to go from 0 to minus pi, and it's going to be counterclockwise. So this should work, and it does. So another thing I'm going to do here is rotate by A. Okay, and now we have a couple more circles, so let's do them. We first have one that's at the same point, 0, and it has a radius R1 over 3, and it's going to go to point. Okay, that works. Now we are going to need a second one, and here fill style, sorry, is going to be black, and the next thing that we're going to do is do the white part, and we're only going to have a single circle, which is going to be on the opposite side. This is going to be white. And now we could draw another big circle in the back, but something else we can do is just set white on the canvas and give it a border radius 50%, and this does it. So yeah, this is the animation with canvas, and as you can see, it scales nicely. And yeah, so I hope you've enjoyed this video, and if you have any other ideas, just drop them in the comments or just on Twitter, and until next time.